Hello everyone, and this is the final lesson in the KineFX series. And what we're going to do is we're going to take a look at how to build this spider leg rig and then how to rig it using Fullbody IK. Okay, so that's primarily what we're going to do. Now the Fullbody IK setup is actually very simple. So what we're also going to take a look at is how to build this entire rig procedurally. Okay. So I just have to, it's like 99% procedural because I have to make like some minor adjustment. So if I take one of these legs and sort of duplicate it, and add it in over here. So I need to make like a couple of minor changes, which is I need to sort of, take care of these roots over here. So this is point number 15. And then I need to make some adjustments here, which is for the Fullbody IK. So hold on. Okay, so if I've done all of that, if I come back to my bones and see, there you go. So I should be able to, so it was like two minor things that I need to change. But the rest of it pretty much like the legs generate automatically and all of that stuff just happens automatically. Okay, so this is what we're going to do. We're going to build a procedural spider leg rig and then use Fullbody IK to set it up. Okay, so I'll start off with a new file. And the first thing I want to do is I just want to create a leg. Okay, so I'm going to come to the right view and let's create a piece of geometry. Let's call this spider. And then I'll say create in context. And then let's just create a curve. Okay, so this is fine. This is going to be my leg setup. Now the first thing I want to do is I want to generate the legs, like the actual geometry. So what we can do is I can use like a path deform, okay, to do that. But what I need for the path deform is I need to get each sort of line segment into its own primitive. Okay, like right now this is like one primitive. So what I want is this one, and this one. They should each be like a separate primitive. So the way to do that is I can press 2. I can select these 2 points. Let's create a group out of it and let's call it cut. Okay, and then type in poly and you'll find something called as polycut. Okay, so take a polycut and it has this option for using cut points. So connect this and use the cut points that we had made, and the strategy instead of remove should be cut. So you'll see this. See, so it's like 0, 2 and 1. Now this is where our first and only problem happens, which is it should be 0, 1 and 2 because otherwise the naming is going to be problematic. Okay, so what I'll do is I'm going to separate these out. So we'll do delete non-selected and do 0 and 1 and 2, and then we'll merge them back in the right order. So this will be the first one and then this should be the second. Yeah, and then this should be the third. So it should go this way. Okay, so this gives me the leg setup. Okay, now how do you make a geometry sort of go between these? Is you can use a path deform. Now the good thing about this is that even if you have like any piece of geometry that you want, you can just have it stretch between the length of the line. Okay, so if you just have some kit bash model and you just want to have like the center piece just stretch out between those lines, you can do that. Okay, so what I'll do is I'll just take a box and I'm going to do copy parameter in the y-axis, paste relative reference divided by 2, and then just make it smaller. And then just take a path deform, and I can just plug this in. So what the path deform does is it's sort of got like an inbuilt for each, if you want to put it that way, is it just, if there are 10 lines in there, it will automatically duplicate the box to each line. Okay, so you don't need to worry about it. So what I'll do is I'll just, if I click here, you'll see like each one sort of automatically, goes that way. And what you want to do is you want to say map length using fraction of curve length. See, so that gives you, so it stretches out this way. And I think it's going in the wrong direction. Let's try something. Let's take a transform and we'll rotate it. Yeah, so rotate it 90 degrees. Yeah, there you go. See, so this is fine. Okay, now what we can also do is I can say enable scale, and we can take the ramp and I can probably scale it down like that, and maybe make it thinner. So this gives me the legs. Okay, so now comes the important bit, which is this is set up, and then we need to pack them, right? Like if you pack it beforehand, then it won't scale down, like it will remain like that. Okay, so packing has to be done, after the fact. So what we'll do is we'll take a, we need to separate out each one of these based on say connectivity, and then do a pack. Okay, so we can do a for each based on connected piece. So it will give you like a connectivity over here. So it should give you, each one separately, and then we can pack it. So I can pack this. Okay, so now if we come out here, this is all packed geometry. Like if we click here, see this is 3 packed pieces of geometry. Okay, now along with this, we also need to give it a name. So what we can do is we can name it based on the primitive number. Okay, so I can just take a partition and we'll create a group for each one of these based on the primitive number. So I can just come in here and let's call it leg backtick at prim num. Okay, and then I'll just take a name from group. Okay, like you'll see what it has done is it made a group for each leg, and just change this to leg. So now what you should have is, if we check our split pane left right, and if we check the geometry spreadsheet, in the name, see you have like leg 0, leg 1, leg 2. And if you want to check the primitive numbers, we should, you'll have to go to like wireframe mode. Okay. Or actually we can just check the point number. See, there you go. So this is 0, 1 and 2. Okay, so now what we want to do is we want to mirror this in the Z axis. So let's take a mirror. So all of this has to be done beforehand, because if you mirror over here, the names won't change. Okay, so we need something that will, like all of this has to be done later. So the naming will have to be done later. Okay, so this should be 1 over here and 0 over there, and we'll drop it in. And the one thing you need to do is you need to make sure that reverse normals is kept to no. Okay, because otherwise you'll see like the legs change shape. So you want to make sure that this is kept to no. And the rest will just work. Okay, so this is fine. Now comes the point of creating the bones in the middle, okay, or the joints. Now the problem here is, like, this is fine. The problem is that we need the numbers to match. Okay, that's very, very important. But we also don't want the final point, because the joints that are needed is only 0, 1 and 2. Like we don't need the last one. We need the last one for our IK setup, when we do the full body IK. But for our bone capture, it's not really required. Okay, so what needs to be done is like these top 3 points, their names have to match with the names we are generating here. Okay, so this 0, 1 and 2 has to match the 0, 1 and 2 over here. And the problem is, because this has 3 points and this has 4 points, it's going to cause an issue. So that's what we primarily need to take care of. Okay, so what we're going to do is after the mirror, firstly, I'll just take a fuse. So we'll just, fuse these together. Okay, so see, this is 0, 1 and 2, but this is 3, right? So this becomes 4. And the problem is that our numbering here, this is 3. Okay, so the bones won't match. So you'll get like, the capturing will be all wrong. So what we want to do is firstly, we want to fuse them. But fusing doesn't get rid of the primitives, right? This still remains. So you have to make sure that you take a join. And in the join, make sure you turn on only connected. And that will take care of this. The next step is to make sure that we set up a group for these bottom points. Okay, so let's do one thing. Let's take a group by expression. Hopefully that should work. Okay, so let's take a group by expression. And these are the lowest points, right? So I'm going to take, let's call it roots. And we'll call this at p.y less than 0.001. Sorry. Yeah. And set this to points. Or let's try 0.1. Okay, there you go, 0.1. Okay, so there you go. So those are selected. Now, the other thing is we want these to be called legs. Okay, like the same way we have done here, like this is leg, right? So the name here is leg. So these should be called leg and then these should be called root. Okay, so what we're going to do is, but then at the end of it, we want all of it to merge together. So we need a way by which, these points will remember that they're all part of like a single family, so to speak. Okay, so what I'm going to do is I'll create separate groups for each of these legs. Okay, again, using a partition node. Let's just call it like L backtick at prim num. Okay, and then change this, like copy that to a name. So name from group, and this will be L star. And then that needs to be transferred to point level so that even if we delete this point and later on merge it together, it will know that, all the ones called, L1 or L2, those are all together. So I'm going to take an attribute promote and I'm going to promote from primitives to point the name attribute. Okay, so now these are all name. Now, the other thing is eventually we're going to give it like their own names as well, right? So this will be leg, this will be like leg 0, leg 1, leg 2. So let's do one thing. Let's take this name attribute and we'll store it to something else. Okay, so I'm just going to take a wrangle sop and this name, let's just call it, it's a string attribute. So we'll call it s at old name is equal to at name. So what's happened now is we should have at point level, we have like name and then we have this old name. So this will all make sense. Like just let me do this so you'll eventually understand what is happening. Okay, so now what I want to do is I want to take a blast and I want to get rid of the roots. So just take a blast here and get rid of the roots. Okay, so we have like this. Okay, and see now you can see like this is 0, 1 and 2, 3, 4, 5 and over here this is 0, 1, 2, 3, 4, 5. So we are matching perfectly. As I said, like that's very important because if these lines and these names don't match, then the bone capture won't work. Okay, or you'll have to like manually pick the bone capture, which is going to be a long process. Like we're going to have a lot of legs. Okay, so we don't want to do that. Okay, so once this is done, let's do Control-C, Control-V. We'll do delete non-selected. Okay, so both of these, this is fine. Let's take a partition here. And the same thing will happen. This will be at point level. And we'll do leg backtick at pt num. Okay, and then take a name from group. And we'll call it and leg. Okay, so this is fine. That's done. Let's just check it. See, there you go. So this is leg 0, 1, 2, 3, 4, 5. And we still have that old value stored over there. And then this comes in here, Control C, Control V for the roots, and we'll call this as root, and this should also be root. Okay. Okay, so this is done. We have this and this. Now what we can do is we can merge them together, and now we need to reconstruct the full leg, because that's how the bone setup is going to be. So what we'll do is we should have our 1 point and the connected line. Let's take a for each named primitive, except we're going to change it from primitive to points, and the piece attribute will be called old name. So what will happen is when we connect this, you'll see these 4 points are in place. Okay, and then if you come back here, you'll have those 4 points. So now at this level, we also want to finally create our root, or actually our center, which is the head. Okay, so let's just take an add node, and we'll just create a point. Let's just push it up. Let's give this a name as well. Let's say point level, and this will be called head. So let's merge all of this together. So we merge this and that. See, so we'll have this coming in, and then take an add, and this will construct the whole line. And if we bring it out, see, we have this guy, and then we need to fuse it, because this point will be doubled. So let's just take a fuse. So if you've done everything right, these points are called root, and these are the legs. And then let's just bring all of this down over here, and let's do a capture. So we'll do capture pack geometry, and firstly convert this into a rig. So just take a rig doctor. Our names are already there, so you don't need to initialize anything, and just make sure you turn on initialize transforms. Okay, and then I can just plug this in and that. And if everything is right, if I say capture by attribute, press W. Sorry, this needs to go to smooth shaded. There you go, everything turns black. Okay, and then if we do a bone deform, so this and that, and let's take a rig pose, and we plug it in, and let's just see if everything works. See, there you go. So everything is working. All the legs are rigged to the exact thing that they need to be rigged to. And also, if I have done everything right, if I was to adjust, let me just come to the rig pose and get rid of everything. I'll just do a clear. Okay. If I have done everything right, and let's say we add more legs over here. Okay, after this, I'm going to add more legs. So I'll just take a transform up here. Let's take a transform, and I'll just manually copy a few things. So I'll just take this out there, and then do Control C, Control V. Or actually, no, let's just take another transform. And we'll bring this here, and yeah. And then we'll merge these together. You can merge them in any order. It doesn't really matter. So if everything is right, and if we come back to the bone deform, see, we have extra legs, and if we come into the rig pose, everything should work, just fine. Okay, now we want to just add in the head. So let's just add in the head. So what I can do is I can just take a box. Let's also take an attribute delete and get rid of the color that this is generating. Yeah. So we can just take a box here, and I just want to see where my, this is. Okay. So what I can do is I can copy it over there, but we'll just do it manually. It doesn't really matter. Okay. So let's just keep it there, and I can just squeeze it in like that. Let's take a transform, and we'll just tilt it back slightly just for fun. Okay. And let's pack this, and then we'll name it. So the name, as I said, like the name should match the name we've given here. So it's called head. So this will be head. Okay. And then just, merge it with this guy. And if we come up here, see, there you go. Okay, we have this. So our setup is done. Okay, now the only thing left is we need to set up the full body IK, which is actually very, very simple. Okay, so what you want to do is after the rig doctor, you want to find your main control points. Okay, so in our case, it will be the head and the, the roots over here. So what I can do is, let's just take a blast and let's see if we can do that, right? So I can do, yeah, let's do root star, and we also want 0, okay, and do delete non-selected. So we have all of these. Okay, so once you've separated these out, the one important thing is that they should just be independent points. We don't want any kind of connectivity between them. So take an add node, and I can just say delete geometry but keep points. Okay, so once this is done, there's just a very simple thing called full body IK. So just take a full body IK. You need the rig and you need the points. The rig pose I'll remove from here and put it in over there. Just clear everything in the rig pose. Yeah. And then here you just want to say match by attribute. That's pretty much it. Okay, and then this comes in over here into the deform points, and that's it. So if I take the rig pose now, and if I move it around, see, there you go, you have your full body IK. Yeah, so that's pretty much it. Like, it's pretty simple. Okay, now you can do something a little more fancy with this, just for fun's sake. Is, let's say after this add, which is my 0. Hold on a second. Okay, that's my 0. Okay, so what I can do is, let's just take a blast here. We'll just separate them out for now. So this will just do separate 0 and Control C, Control V. I'll do delete non-selected. Okay. And then I'll just take a grid here and I can do a race op. So I'm going to take these points and attach them to this grid, but I'll do a transform in the middle, and then make sure you set this to minimum distance so that the points actually, attach themselves. Okay, and then merge these back together. So we want, these points and these points come back. And what this should do, fairly interestingly, is if I take this grid and I start to rotate it, see, you'll get that. So you get like a little balancing act happening over there. Now, if it feels a little jerky, you can come into the full body IK and you have this like damping factor and tolerance. So you can increase that and that will sort of smoothen it out for you. So it's not like, see, there you go. So it's not the best thing, but for relatively simple animation, it's not bad at all. Okay, like you will definitely get more control if you do like a full IK rig and everything. But if you just want to do something very, very simple, this is not, this is not bad at all. And as I said, like if we have done everything right procedurally speaking, then if I just take this and I do Control C, Control V, and actually not this one, let's take this one. And maybe like, just for fun, I'll just push it back a little bit more. Yeah, and just merge it in. There you go, see. And not only did everything work, I think, even the race op and everything is working, see. So we have like all of it in place. So this is not just good for doing like a spider leg rig, but if you want to do like a centipede or a millipede or whatever, then you can just, like I'm doing manual copies, but if you just want to take like a copy and transform and just, copy them, even that will pretty much work. Like if I just take, just for fun over here, if I do a copy and transform and see if that works, like if I just do this, and let's say we do about 4 of these, and I plug that in, I don't know if it'll work or not. Logically it should. If I come back here, see, there you go. And is this working? See, you know. So you want to do like a centipede, millipede, whatever, like, you know, you can do that very easily as well. I can probably just take a transform and adjust it a little bit. Like I can take this, push it back. Yeah, there you go. See, so we can actually like do something like that. I can add as many as I want. See, this is where it gets, you know, nice and procedural. So yeah, the head is now not matching, but the rest of it works. Okay, like if I just take this and again, you know, see. So yeah, if you put a little bit of thought into it, you can actually build like a fully procedural rig, okay, and makes it quite easy to do it this way. Yeah, so that's pretty much it. So this is how you can do like a fully procedural multi-leg rig, and how to do full body IK. So as I said, like the full body IK is very, very simple. Like that's not really the big problem in this. But yeah, the logic for setting up like a full, you know, multi-leg rig, that's, you know, always nice enough to know. Okay, so this is the final lesson. If I learn more stuff about, you know, about KineFX, I'll make a few more lessons. But for now, this is what I, you know, initially planned as far as like mechanical rigging and stuff is concerned. So yeah, that's pretty much it.